We are about to discuss econometrics. Today, we'll be discussing module 7, which is instrumental variables and 2 SLS. By way of module objectives, by the end of this module, students should be able to explain the sources of endogeneity in econometrics models and why OLS becomes biased and inconsistent when regressors are endogenous. Students should be able to define instrumental variable and state the 2 core conditions for a valid instrument. Students should be able to derive a single instrument IV estimator. Students should be able to extend the IV to multiple instruments and controls. Students should be able to distinguish structural, reduced form, and first stage equations and explain how they combine to identify causal effects. Students should be able to implement and interpret first stage diagnostics. Students should be able to explain and apply tests of instrument validity over identification tests. Students should be able to interpret IV estimates carefully, discuss external validity, and explain why IV estimates can differ from OLS. Students should be able to design and report an applied IV2LS study with transparent identification assumptions. By way of introduction, endogeneity is the central obstacle to causal interpretation in econometrics. In a regression model, we usually want the slope coefficient to represent a causal effect. How would the outcome change if we change an explanatory variable while holding everything else constant? Ordinary least squares, OLS, delivers the interpretation only when regressors are exogenous, uncorrelated with the unobserved determinants of the outcomes. When this condition fails, OLS suffers from bias and inconsistency, and the confidence intervals and policy conclusion can be badly misleading in very large samples. Endogeneity arises in applied economics for 3 reasons. First, omitted variables, unobserved factors, affect the dependent variable and are correlated with the regressor of interest. That is ability in wage regression, managerial quality in productive regression. Second, simultaneity and reverse causality. The regressor and the outcomes are jointly determined, e.g., price and quantity market, interest rate and inflation. Third, measurement errors in regressors. If the key regressor is measured with the error, the regressor is mechanically correlated to error term, generating attenuation bias. Instrumental variables methods solve this problem by introducing an instrument, a variable that shifts the endogenous regressor but does not directly shift the outcome except through that regressor. IV estimation is one of the most important tools in modern empirical economics because it provides a rigorous framework for identification, not merely estimation. It forces the researchers to state clearly where the variation identified the causal effect came from. This module provides a rigorous step-by-step treatment of instrumental variables and its 2-stage least square, that's 2 SLS. We begin with economic logic and formal conditions for instrument validity, then derive the IV estimator in both single instrument and multiple instrument setting, then build up to 2 SLS in matrix form. We also treat diagnostics in depth because IV is only as credible as its instrument. Weak instrument and invalid exclusion criteria and instrument proliferation can undermine the results. We therefore study first stage relevance over identification tests, endogeneity tests, and robust inference methods that remain valid under weak identification. Let's look at probability limit of the OLS under endogeneity. This is the equation. If this part of the equation is not equal to 0, then OLS converges to a bias limit. Biases does not vanish when sample size grows. Economically, this X contains variations driven by unobserved affecting Y. Economic sources of endogeneity. We have omitted variables. The ability affects schooling and wages, example. Simultaneity, example, price determined jointly with quantity. Measurement error, observed x is equal to x plus noise. This is an attenuation bias. Selection, individual self-select into treatment. Now let's look at IV as identification strategy. IV estimates the part of X generated by an external source. Let's say Z. Think of Z like a natural experiment shifting X exogenously. IV replaces endogenous variations with exogenous variations, endogenous variations with exogenous variations. IV conditions. This is for relevance, this is for exclusion. Relevance ensures identification, exclusion ensures consistency. Relevance is testable, exclusions justified economically. Let's look at structural first stage, reduced form system. This is the equation here. Reduced form combines first stage and structural effect. If exclusion holds, then this symbol is equal to beta of pi. Foundation for VI ratio interpretation. This is the very foundation. Let's look at the word estimator. This is the formula for estimating it. P subscript IV is equal to this divided by pi. The effect of Z on Y divided by 0 divided by effect of Z on X. The binary Z differences in means ratio. There's clear causal interpretation. Let's look at the covariance form. This is derived from moment conditions. Instrument replaces X in covariance formula. Why IV is consistent? We have moment conditions where this is equal to 0. Because Z uncorrelated with endogenous variation is purged. As sample grows, sample moment converges to population moment. Condition and rank conditions. With multiple endogenous regressors, it needs enough independent instrument. This rank of this formula here must equal number of endogenous regressors. Without sufficient rank, parameters are not identified. Let's look at the two SLS stage. 1. Regress X on Z and controls. Obtain fitted X is equal to P ZX, where ZS are subscripts. The X contains only instrument-driven variation. Now let's look at the stage 2. Regress Y on X and controls. Produce beta subscript 2LS, 2SLS. These are, you see this sign, just know that what follows this is subscript, right? Must use IV variance formula, not OLS-SE. Now let's look at the matrix formula. This is the equation. This is the very equation here. This shows projection of X into instrument space. Let's look at the geometric interpretation. OLS, residuals orthogonal to regressors. IV, residuals orthogonal to instrument. 2LS enforce these formulas, making it 0. This particular one here. Let's look at weak instruments, the final sample biases. If curve ZX is small, denominator in IV ratio is small. This is an unstable estimate. For final sample biases, push IV towards OLS. Inference unreliable without robust methods. The first stage diagnostics. This reports the pi, partial R squared, and F statistics. If F is less than 10, it signals weakness, single endogenous case. It uses weak instruments, robust inference when needed. Let's look at over-identification and endogeneity test. Hazard J test, joint instrument validity in over-identified models. Dubbing Wu-Hosmer compares OLS and IV. Tests cannot prove exclusion, there can only be test inconsistencies. Let's look at late interpretation. What does it mean? With binary instruments, IV identifies effects for compliers. Late formula, this is the late formula. This is how to calculate late. IV and OLS may estimate different causal objects. That is why late interpretation is needed. Now, by way of conclusion, instrumental variables and two-stage least square are foundational tools for causal inference when regressors are endogenous. This IV stage replaces endogenous variation with exogenous variation induced by instruments, allowing consistent estimation of causal parameters under clear assumptions. In the simplest case, the IV estimator is the ratio of the reduced form effect of the instrument on the outcomes to the first stage effects of the instrument on the indigenous regressors, making the identification logic transparent. Two-stage least square generalizes IV to realistic settings with multiple regressors and instruments. Its projection interpretation clarifies both its power and its risk. If instruments are weak, the projection is noisy and conventional inferences become unreliable. Therefore, credible IV work must report first-stage diagnostics, use robust or cluster robust standard errors, and when appropriate, apply with instrument robust inference method. Finally, instrument validity depends on economic and institutions, not only statistics. Over-identification tests and engeneity tests provide partial evidence, but they cannot substitute for a well-argued exclusion restriction supported by divine features, timely, placebo tests, and mechanism evidence. Good practice is transparent, state assumptions, show diagnostics, interpret estimates carefully, including the when relevant, and discuss limitations. That'll be all for 7. I'll see you in 8.